Hello. So in this week, we're gonna go over the unit number three, which is covering correlation. Highly likely you have been introduced to the concept of correlation historically in some of your statistical courses. However, in the data mining course, we're going to look over correlation from the perspective of business case studies. So, in this case study, we're going to talk about a specific sales manager where she wants to look at some elements in the data that she has, and we're going to look at the correlation in that data, and then in future we're going to look at how we can create linear regression, for example, or logistic regression, or any type of data mining modeling techniques. So in this unit, you will have a lecture to read, which is I'm gonna go over it now, and then you're gonna use a step-by-step process that included in this lecture for you, and finally you're gonna answer assignment number 3, which is about 50 points. So if you click inside the correlation unit, you will see first the theory part and then the applied part here, which is just doing the assignment. Since the theory part, the lecture, it has a step-by-step application in within, so I didn't split them into separate two units, one theory, one application. The application was in the case study. So we're gonna talk theoretically about the correlation and how you read correlation metrics, and then you are going to apply it with RapidMiner. Okay, so let's open this part. And as I said, you have the link to the whole lecture and also the link of this PowerPoint presentation where I'm gonna show you how you can do those steps in just an easier way. That's all. Okay, so what is this case study all about? So let me maximize this part and maybe just making it, and I don't want to blow it completely. Maybe, yes, okay, I think this sounds much better to me. Okay, so Sarah is regional sales manager for a specific company called the Nationwide Supplier. Her job is to provide fossil fuels for home heating. So imagine that uh, the same concept how in summer people buy air conditioners maybe in their offices and they plug them small units, not like the whole house. Similar concept you might see in winter, people buy this small unit of fossil fuel type of heatings, or sometimes it could be a complete infrastructure that uses that type of technology to provide heating. Okay, so she recently looked at the price of the heating oil in the market, and she looked at how many units from her inventory people are buying over time, and she noticed there are a lot of wide variability in the size of each order for home heating oil that her customers order from her company. So she was concerned a little bit. She wants to know and she wants to understand the behaviors of her customers and what are those factors that really influence the demand for heating oil for domestic market in general. Okay. Again, as we mentioned in the first lecture, that we always go over the CRISP model for data mining, all those stages. So before even we start helping Sarah and knowing how to look at her data, we have to remember first what is her business problem. So what type of questions we are going to answer to help Sarah. Then we're going to look at the data she's going to give us. We look if we need to prepare the data. If there is missing data, inconsistency, those should take care of them before even modeling this data. For today's lecture, we're going to go over those four stages. We're not going to really evaluate or deploy we'll see those more in more sophisticated models. The correlation model is very simple model, just gives you some insight about the data. So the question here, the business question, what factors are related to heating oil usage and how might Sarah use a knowledge of such factors to better manage her inventory and also to anticipate demand. So, for example, she doesn't want to have a huge inventory of those heating units where the demand is very low, so she will be losing money by buying them and stacking them in her inventory. At the same time, she wants to have some type of inventory that will not even to put her in a situation where she doesn't have enough to supply her customers. Okay, so she believes that data mining can help her begin to formulate an understanding of these factors that can really provide her some information about what's going on in the market in regards to the heating oil usage. Okay, so as we said, we start first with the business model. By the end of this lecture, you should be able to understand what is correlation and what it is and what isn't, and to recognize what necessary format your data need to to have to be able to perform correlation analysis. Then you're going to develop what is called the correlation model or correlation matrix. We look at the coefficients and we're going to interpret those coefficients and we're going to explain what the meaning of their significance and if there is any significance in those data. So now we move to the step number 2 is what type of data set Sarah gave us. So Sarah gave us this data, and this is what is called the dictionary of the data, which means information about the data on hand. So this data has a couple of attributes. The first one is called the insulation. So this is the density rating from 1 to 10, which is this is related to the house that ordered this heating unit from her inventory. So she has information about those houses. Our first attribute is called insulation. If the number of that attribute in this data set is 1, that means this house is poorly insulated. Now, if it's 10, it has an excellent insulation. Okay. Number 2 is temperature, and pay attention here. The temperature here is the outdoor temperature being measured at that time when the data was collected, and for each home that when they did the order, so the temperature at that location was measured in Fahrenheit and added to the data. So as you can see here, maybe the temperature important, maybe not, we don't know. Then the heating oil, how many unit that house purchased in that specific period of time when they ordered, okay, and that specific year. So then number 4, we have number of occupants, how many people live in this house, okay. Average age, the average age of those occupants. 6, the home size. So this is a rating on scale from 1 to 8. The higher the number, the larger the home. So 8 is the largest size of houses that bought heating unit from her. So now we understand a little bit the data and what the meaning of those numbers inside this data. So when you open the data, you will be able to interpret the meaning. So this is the data opened in RapidMiner, and we're going to go over how we do that in details just to give you a better understanding. So this is the data we have, how many cases, how many houses. In our case, as you can see on top, it says we have about 1,218 examples. It means we have 1,218 houses or case studies. 0 special attributes. We'll get into this in RapidMiner when we create our own attributes called special attributes. We didn't create any in the time being, so we have 0 of those. We have 6 regular attributes. Those regular attributes are the one I just mentioned here, those 6 attributes: insulation, temperature, heating oil, number of occupants, age, average age, and the home size. So those are the one you see at the header of this table: insulation, temperature, heating oils, number of occupant, average age of the occupant of this house, and the home size, as we talked about, from 1 to 8, where 8 is the biggest house. Okay, so pay attention when you open any data in RapidMiner. You have the information about how many examples we have in this data. In our case, how many houses, the information about Sarah got about this house, and we also know how many attributes in this data. So you go ahead and open the data with RapidMiner. A little bit maybe different, just the view, but exactly the same concept. If you click on the statistics, you should be able to look at the data. So we have the insolation as an integer value. The minimum is 2, the maximum is 10. Okay, the temperature outdoor when that house purchased the unit, it varied in all those houses between 38 to 90. This is the average, this is the standard deviation. How many heating oil that each house ordered. So on average, minimum heating units were 114, and the maximum order of those houses was about 301. So on average, 197 units been purchased from Sarah. Number of occupants, so some houses had just 1, some houses had maximum of 10. Average of age of those occupants, someone had minimum of 15, and some maximum, highly likely they had babies in these houses, and maximum was 72. Okay, home size ranged from 1 to 8. So far, we have no missing data, which is great. That means we don't have to handle any type of substitution for the missing data, such as we did in our previous lecture, like the mean and mode based on the type of attributes we are dealing with. Okay, so that's the summary. There are total of 1,218 homes. Our data appeared to be very clean, no inconsistency data. We didn't see any text here that's supposed to be number. Well, it looks to me the data is good. Other descriptive statistics like histogram or density plot, etc., can be really generated from this model. So it would be good advice to do it. The time being, since we are looking only on the correlation, so we're gonna skip it, but I will show you in future how we can do that. Now, in your textbook, which I showed you, sorry, in your chapter that I gave you, you will see that I introduced the other type of reading data that you can do in RapidMiner beside the Excel. So in the data set, there is a part that you just bring a node called read CSV, because our data is comma separated value type of data. So that's why when you read the data, you need to read it with that specific operator. So our case today is only those two nodes, one to read the data, then one to link to the correlation matrix, which you can get it under the modeling. And the trick is always, if you're looking at any model, just to write the beginning letters in the search engine in RapidMiner, and automatically RapidMiner will show it to you. And we're gonna do it together in a split of seconds. Just I wanna show you the theory now before we go in doing the hands-on activities. So after you run the correlation matrix, the one here, this is what the output of the results. So this is what is called the correlation matrix. Correlation matrix, all it does, it finds a relationship between variables. So if you look at the diagonal here, all of it is 1, because technically it's the relationship between the variable or the attribute with itself. So insolation, of course, the correlation is 1 because it's the same attribute, and this is meaningless information. But for you, to be easy for you to read this data, all you have to do is to read either the upper triangle here from this diagonal or the lower triangle. Okay, that's all you need to read. So from here, all you have to know is to find relationship between, for example, what is the relationship between the insulation and the heating oil? Okay, so as we can see, there is 0.736. What does that mean? Is it good or bad, positive? Okay, so what that mean? So we're gonna explain those. But this is how you read the information. Okay, number of occupants, with the heating oil. So this is, you cross this one with third row. So it's negative 0.042, what that means. So we're going to talk about in the next slide what that means. Also pay attention that RapidMiner gives higher density of color to the bigger number of correlation. So as you can see in one, the color is very strong, where when it's white, that means correlation is almost, there is no correlation. The second number after the one here, as you can see, maybe this one here, the average age correlated with the heating oil, which is 0.848, and it's positive. Positive and negative, we're going to explain in a second. Both of are, if they are high, meaning negative direction or positive direction, that doesn't affect that it is high correlated. So when you look at this, you say I have 0.673 negative correlation between the average age and the temperature, which means there is a high correlation. However, as the average age go up, the temperatures go down in that case. Okay, so that's all what it means, the negative. However, the value is important. The bigger the value over 0.5, that means here we have some type of correlation, and the higher it is, the more correlation we have. That's explained actually in the following, I will skip one slide, in the following diagram. So always, if you want to look at the correlation always range between 1 to -1. That's it, between 1 and -1. Now, when you have a correlation of 0, that means those two attributes do not correlate with each other at all. Okay, now also if the correlation between 0 and 0.4 negative or positive, also we consider it, no correlation, it's very low. However, when we start to get values between 0.4 to 0.6 in both directions, negative and positive, we say that there is some type of correlation. Now if it gets bigger than 0.6 to 0.8, again, negative or positive, we have a strong correlation. And if it is 0.8 to 1 in both directions, it's very strong correlation. So all you have to remember is this chart when you analyze the data. So when you analyze the correlation between the attributes in your data. So remember clearly that when you see numbers bigger than 0.6, here we go, we have a strong correlation, okay? So anything bigger than 0.6 to 1 in both directions, we'll consider strong correlation. Sometime less, like is 0.5, you would say there is some correlation, it's not so strong, so you cannot rely on that decision. Okay, here is the example when I told you what the meaning of the negative sign in the correlation. Like when you see here, as we said, for example, this one, heating oil and temperature, it's a high, it is just based on this chart here, it falls in this area, or sorry, in this area. So it's just a strong correlation. Okay, it is a strong correlation, negative strong correlation, which means the higher the temperatures goes, the lower the heating oil demands go, and it makes sense if you think about it. So that's the whole meaning of this information of how to interpret correlation. So in short, a correlation, how you can interpret it, it's a measure of the strength of the relationship between each possible set of attributes in the data set. And that's why when I said to you over here that this is how you look at it, it's like the same attributes written in top in the column are written in the rows, so you are crossing them together, and of course the same triangle, the upper is identical to the lower, because temperature with heating oil is this value, and again the temperature with the heating oil is this value, and those two are identical. Okay, so that's why all you have to do is to read across the diagonal one of those triangle sets to get all the information. So this is number one. Our matrix is 6 column wide, 6 rows tall. In the location where an attribute intersects with itself, the correlation coefficient is 1, but it's meaningless because you are looking at the attributes with itself. It has no meaning. All the other pairs of attributes will have a correlation coefficient of less than 1, so remember that. Correlation coefficient can actually be negative as well, and all correlation coefficient will fall somewhere between -1 and 1, as I showed you in this diagram here. Now for the signal, so when we say we notice that the sign of the correlation is plus, is a positive. So we based on this look, if the heating oil used is rises, the insulation rating also rises. So both of them are the same direction, so that's why the correlation is positive. Or it could be also positive if both of them go down. Like if the heating oil use falls, the insulation rating also falls. But again, this is always the value of the correlation number, or the coefficient will be a positive value. Now, if they contradict each other, like if the temperature rises, insulation rating falls, so as you can see, different direction, here where you see the negative sign, the correlation. The same in this case, temperature falls, insulation rating rise, negative correlation. And the negative has no influence on the importance of the correlation. The correlation is always, doesn't matter about its sign, if it's positive or negative. All you care about is that you have a correlation. If it's higher than 0.6 in positive or negative, that means there is correlation between those attributes. They correlate with each other, okay? So now what the next action? Like we give her this result, we told her we have this type of correlation, we have to interpret those results so she can maybe take action accordingly. So there is several possible outcome from this investigation using the correlation model. We notice that the most strongly correlated attributes in our data sets are the heating oil and the average age, with a coefficient of 0.848. So when I tell you to rank those correlations from top 6, so you have to start with the biggest number, including the negative ones, and to the lowest correlation. So if we go back to our matrix over here, look carefully. So we have the 0.848 is the highest correlation in this data between the average and the heating oil. So the average age of the occupant of the house, when the average age is going up, so we have maybe older people in that house, the heating oil purchases, and so they consume more of heat. Okay, that's all it says, this number, and in the same direction because it's positive. Now the second number higher comes directly after that, is here, which is temperature is related to insulation, and it's negative. So the insulation, okay, if the temperature is low outside, the insulation is high, okay, and that's what it means. All it means is correlation, and it's a high correlation because it's bigger than 0.6. So it's between 0.6 and 1, so it's high, and doesn't matter the negative sign. It's considered this is the second highest correlation after the 0.848. After that, you might see we have this number over here, the heating oil and the temperature, okay? After that one, you will see the 0.736, which is insulation and heating oil. So you have to interpret those results, and let us try to interpret those together. So here what you can say, okay, there is a strong correlation between the heating oil and average age with coefficient equal to 0.848. As the average, so this is the interpretation, as the average age of the occupants in the home increases, so too does the heating oil usage in that home increases. Okay, makes sense. So what we do not know is why that occur. So data analysts often make a mistake, so pay attention, of interpreting correlation as causation. The assumption that correlation proves causation is dangerous and often is false. So it's very important. You cannot say, or we can interpret from the correlation that there is a relationship between the heating oil and average age, but we cannot say that because the reason for the usage heating oil increase is caused because of the higher average age. We cannot make that assumption. So it's not causality. You cannot prove causality in this way. So now let's the second one. Consider for a moment the correlation coefficient between average age and temperature. So between those two, so go back to the table, look at those two, the average age, okay, and the temperature, this one here. So it is higher than 0.6, so it's considered a strong correlation. But what that mean? Remember, temperature is the temperature outside the outside the house. So can be the temperature inside the house related to the age of the people living in that house? Of course not. So yes, the correlation model gave us a number and says there is a high correlation, but there is no meaning for that, okay? There is no logic interpretation for that. So pay attention. We're not going to just pick up those numbers and say, yes, there is correlation. You have to understand the meaning of those numbers. So we see that it's considered this number as relatively strong. So if you want to interpret it, as the age of the home's residents increases, the average temperature outside decreases. And of course, you can say as the temperature rises, the age of the folks inside goes down. So pay attention, that's a logic to make that type of interpretation. So the question, but could the average age of the home's occupant have any effect on the home's average yearly outdoor temperature? Certainly not. Okay, so pay attention when you interpret those results. Okay, so another false interpretation about the correlation is that coefficients are percentages. A lot of people make that mistake, so make sure not to do it. So when you see the coefficient of the correlation that equals 0.776 between two attributes, that doesn't mean that the correlation is 70.6%, okay? All it means that there is a strong correlation, but you cannot make the following judgment. You cannot say that 77.6%, you turn this to percent, shared variability between those two attributes. Okay, it's only what indicate. This is not correct. So if you hear that terminology in any place, that's incorrect. You cannot convert those correlations coefficients to percentages. All it says that there is a strong correlation between two attributes. Okay, that's all. So no percentage is calculated or intended in the table, in the matrix table. Okay, that's incorrect, and a lot of students make that wrong assumption. So that's why I added to your lecture. Okay, so here is what usually what you will do if you're working for any company and someone gave you this data and told you, okay, run some models and give us some insight about this data and advise us what we should do next. So for Sarah, as you remember, she was concerned about this variability of the inventory numbers because of the market purchases of her heating units. So what can we advise her to do next? That's the goal of the data mining business project in general. So we might tell her, maybe based on what we saw so far, maybe it's a good idea to drop the number of occupant attribute. It's really, it doesn't really make any sense to contribute to the usage of the heating oil. So another thing that maybe she need to investigate further, this home insulation attribute variable. Okay, so the insulation rating attribute was fairly strongly correlated with a number of other attributes. That's what we notice in this data. So take a look again on this table. Here's the insulation. See all those numbers we saw. So insulation with temperature, and we said that doesn't one of the relationship negative relationship, insulation, heating oil, insulation, average age. So it's correlated with many other attributes. So maybe it's a our advice to Sarah, it's going to look more into that specific insulation and see what's going on. And if it's strongly correlated, maybe she will consider the following advice. So maybe there is opportunity to partner with company, or maybe to start one that specializes in adding insulation to existing homes. So it's some type of marketing promotion. However, if she wishes to continue to sell as much heating as she can, she may feel conflicted about participating in such campaign. Okay, because if the insulation is going low, her customers are buying more. So maybe she liked that idea, but again, or could be buying a franchise for insulation and add it to her business, as we said, number one. Okay. The second thing we can tell her that uh, so what is probably she has to do next, this data, it didn't give us really timestamp information. We only had it for 1 year, and usually people usage of heating in general, it depends on the weather. So if it's in winter, should vary than the summer or other seasons. So maybe we advise her to bring us new to come up with a new analysis, or to come with to go to those houses multiple times and to measure all those attributes she mentioned in this data set, but in considering the time of the year, or maybe per month, or maybe per weeks, if really she has the good type of infrastructure to send some of her programmers to go and measure all this and all those 1200 houses. Why not? So she will get more accurate data. In this way, she will have a better understanding when she has to have enough inventory, when the demand is going up, when the demand going down, and accordingly work on having enough inventory in advance. Okay, what else? So you might also uh, consider the following. We noticed that the number of occupant in the home didn't correlate much with other attributes, but that doesn't mean that the other attributes would be equally uninteresting. Okay. So, for example, if Sarah had access to the number of furnaces or and the boiler in each home, that really will help her more. So, the home size, we can say, was slightly correlated with heating oil usage. So, perhaps the number of instruments that consume heating oil in each of those houses would tell us some interesting story, or at least add to her insight about those houses. Okay. So this is the type of conclusion that you really actually do with your customers. So again, remember, the crisp model or any data mining project is a cyclic. So you start, you analyze, we created a model, we looked at the model, we somehow is not evaluation, more than interpreting the correlation matrix. We looked at that, and then we keep repeating the cycle. We might tell her go and gather new data based on what we saw in our first cycle. So she will have to go and examine, maybe bring us new data with different time of the year, and then we're gonna redo that and re-prepare the data. So Sarah would also consider that as maybe a cycle for each month, as a new order come in, so there's a new bills go out, so maybe she would keep a track of all this new information. New customers sign up for heating oil accounts, she might track their information and start building her database. Maybe there are some traditional data available to add into the model. Maybe she has more information about those houses. Maybe she can incorporate with this data set that she gave us. Okay, so as she learned more about those attributes in her data and how they interact with each other, she can increase the importance of this correlation model by adding new attributes. okay? Or maybe adding new houses, or maybe adding a new attributes like the time, new observations that will help her her case to be better. So that is the last slide of the theoretical part. We're gonna go to Rapid Miner now to show you how you can do it, okay? So let's open Rapid Miner. And again, if you are using the university lab, you will have to create the repository every time you start using RapidMiner. If you are not, you are using your personal computer, you have less work to do. Just bring the data and we're gonna look at it in a second. And just to mention, the new edition or version of RapidMiner just was released. So you might receive this alert when you open it that you want to update. So it's okay if you update. I heard that they enhanced their visualization tool. So it's not bad to use it. Okay. Okay, let's put it in the window. So from here now, I'm gonna quickly create repository just for those who forgot what we did last week. BDN 420 repository, not in that location. You're gonna look on the location where you put your data. Okay, so we found it under the week 3 BDN, and this is where I'm gonna put my stuff, and I'm gonna finish. So this is will be we're gonna now bring data. So as you can see under data access, I have to mention what type of files that RapidMiner can read. As you can see, can read the data from SPSS, Excel, we saw that before, Stata, CSV. This is one we're gonna use today. And you can have extensions for SAS and you name it, see access, any type almost you can think of, even with databases. You can read with it's very nice. So I put the operator here, and then from input configuration I'm gonna go and look for that specific data. Okay, this one. Next is showing me, okay, you have all this data, making sure everything sounds good for me. Automatically it knew what kind of separator. So we have the data, you have to double check, just link it and run it. Okay, so it looks good to me. Click on the statistics as we looked in the theory. No missing data. You can look at histograms a little bit just to get understanding as we did before. This should be the process every time you look at your data. Okay, so this is the data. Go back to the design, and now we're gonna bring correlation matrix. Okay, just write correlation. And here is the correlation matrix. Add it to the line. So when you see the line is thick, this is where you drop it. Beside the examples, you're gonna link the matrix. Okay, so we need not only examples as it can. So what it does, this is the data is in, we brought the data inside. As you can see it, the data went inside. Also the data goes outside in case you want to do something else with it. So as it comes, it goes outside. However, what we want to see is this matrix that shows us the correlation. I'm gonna save my process here. So store process here, I will name it correlation just to have an access to it. So as you can see, it's here, and I'm gonna run the data. And that's it. So this is what you show and what I showed you in the theory part. Again, we look at the data. You can look at pairwise table. So this is part of your exercise. You're gonna look at the pairwise, and when you click on this, left and right, up and down, you can see it's gonna order it for you. However, the order is by sign, and that's not what I showed you inside the video today or in the lecture. So this is the highest number, the heating oil. 0.848. What is the second heating correlation? Let's see, in the negative, do you have the second here as a positive 0.736? However, we have higher in the negative, which is the insolation and temperature. So that one should be the second one, the top second one. Okay, so you have to write those numbers, pick the top in your example for the exercise you're gonna do for this week. Okay, so let's go back to the data. So this is a correlation, exactly what we mentioned in the theory part. So you have how to interpret those results. First of all, the color really tells a story. So the darker the color is, the higher the correlation in positive or negative, it doesn't matter. So as you can see, this is the highest one between average age and heating oil. Okay. The second one is this one here, the temperature and the insolation in the negative direction. Okay, so those are two. Then we saw that there is a correlation as well. So the third one, this one here, temperature and heating oil, which, okay, makes sense too. The following one is maybe, so you will have to look into each one of those. The 0 points insulation and heating oil, okay, and then heating oil and temperature, and then goes lower. I think this is false. So pay attention to all those numbers, write them down and sort them, maybe in Excel if you want, and just answer your example in this way, your exercise. So that's it for today in this correlation matrix. We're gonna see the correlation more, but at least now you have a better idea how to do it. So if you go back to your class under the correlation, we are done with this video. You should see it available underneath here. All you have to do to download the data set for this week and to repeat the steps that I showed you, and then you create a report, a correlation matrix operator. Then you're gonna create a Word document, put this screenshot of your correlation matrix in your report, then find those correlations between the attributes that have the top value, as I said exactly in my explanation. Upload your Word document and interpret them the way I showed you how you interpret if the temperature goes up, if the temperature goes down, for example, the usage of the heating oil goes up. So that makes sense. However, it's one example. So based on the data here, you're gonna give me this type of analogy and interpretation. So you will not earn your 50 points unless really you give me good interpretation of the correlation. Okay, that's it for now.